Welcome back, everyone. This exercise is a follow-up to the previous video where we formatted a table of scores, homework and exam scores related to a course in a table, entered some formulas, and in this case we're just going to kind of reinforce some of those concepts. We're going to do some formatting, going to also enter some formulas that give us another chance to get more familiar with this whole concept of relative versus absolute addressing. And so what we have here is a spreadsheet that an engineer would use to do some estimating on concrete volumes. And the use case here is you're designing some concrete flat work. Now, what do we mean by flat work? I've Googled some concrete flat work here just to show you some photos. So this would be just flat sections of concrete and we're also, just to keep things simple, we're going to assume each of these sections we're dealing with are rectangular, so we're not going to have any curved parts like this to keep our calculations simple. And in order to estimate the amount of concrete we're going to need, we have this table where each row in the table is a rectangular piece of concrete with a length and a width in feet and then a height in feet. You'll notice the heights are typically a fraction of a foot. And from that we're going to calculate the volume in cubic feet and then the volume in cubic yards of concrete that's going to be required for each section. We're going to calculate the cost of concrete by using this number up here. And then we're also going to look at what the cost of rebar would be. Rebar is short for reinforcing bars, and I think there's some photos here. So this is there's some rebar down here. You can see there's this grid of metal bars. Here's a better picture. So there's some rebar that's going to be inside the concrete to give it some reinforcement. And so yeah, that's kind of the use case, and then in the end we're going to calculate the total numbers. So the first thing we're going to do, let's do a little bit of formatting. Again, let's give it a nice title, and maybe we'll bold this. Maybe we'll write justify this. Now I'm gonna kind of hurry through this formatting because we've already had an introduction to it, but again give you a feel for how this can look. So I'm going to select this section and put some borders on it. I'm going to go over to the View tab and turn off my grid lines again. Now this section right here, I'm going to center justify it. And this table is split into two parts. This part here is associated with the concrete, and this part here is the rebar. So I want to take this part right here, and I'm gonna merge those cells into a single cell. And actually, I want to do it just from here over. Let me try that again, and then yeah, we can do our little trick with the black or with the dark background and the white text. And then let's do this for rebar. I'm going to merge that cell. We'll make this one, let's go with like a dark orange here and light white text. And then now let's go here, let's make this kind of a light green, make this a light orange. And so now we've clearly marked out our two parts. By the way, this is just a header row, so let's make this black and white text. And then this numbers down here, we could make this black and white as well. So there we go. Very quick set of formatting. And now I'm going to increase the font, or zoom in a little bit so we can see this a little better. So now we're ready to start doing some enter some formulas. So we want to calculate in this cell the volume of the concrete, or the volume of this section, which is a length times a width times a height. So we're just going to say equals this cell times this cell times that cell. Now I've got the center justified, and so the formula is kind of bled over. I can't select D of 10 because it's kind of obscured by the formula. So I'm just going to have to type that part in, D10. That happens sometimes. And again, you'll notice when you're entering a formula, it colors the individual cell references and then highlights the corresponding cells in the same color, so you can kind of keep track of what you're referencing. And I can hit enter and then copy that down. Now, by the way, there's another way to do this. When you're multiplying a bunch of numbers together, you can, instead of manually multiplying it like I just did, it's possible to use the product function. So I can type equals product and then give it a range of cells. And so it's kind of like the sum function, but instead of adding the numbers up, it multiplies them all together. And as you will see, that gives me exactly the same answers. And let's see, why is that complaining? Ignore this error. It's not. It's telling me it omits adjacent cells, but I don't know why. It doesn't omit any adjacent cells. Well, I guess it omits this one on the left. I don't know. So there we have the volume in cubic feet. So to get the volume in cubic yards, we take that number and we divide it by 27. So just equals E10 divided by 27. And these are all relative addresses here because I'm just going to copy them down. And I probably don't want that many decimal places displayed, so let's shrink that back a little bit. That's probably good. And now to get the cost is the volume in cubic yards times the cost of concrete per cubic yard. Now, by the way, these are dollar amounts up here, so I'm going to change that to currency. And so I'm going to say equals the volume times the price per cubic yard. Now, when I reference that price, I want that to be absolute. I want the volume to be relative, because as I copy this down to this next set of cells, I want it to always refer to the cell on the left multiplied by exactly this price. So I'm going to, while the cursor is next to that C5, I'm going to hit the F4 key. So it's equals F10 times $C $5. That gives me the right combination of relative and absolute addresses. And so when I copy that down, I now, no matter where I am, it refers to the cell on the left times that concrete price. That's a very important concept when you're beginning to work with Excel. Likewise, the rebar cost is equal to the length of rebar multiplied by the rebar price per foot. Now we're assuming they're all the same diameter here. We're going to revisit this exercise when we're talking about the VLOOKUP function, and we're going to pick a rebar price depending on the radius, but for now we're going to assume they're all the same. And we're going to type equals the length times the rebar price, F4. So once again, I'm going to reference the length using a relative reference, and I'm going to reference the price using an absolute reference. So here we go. Copy that down, and again, in every instance, it gets the length on the left multiplied by exactly the right price. So relative reference to the length, absolute reference to the price. And we're good to go. And all that's left now is we can say, okay, how much is the concrete? So we're just going to use the sum function. Whoops, to add up right here is the concrete. How much is the rebar? Equals sum. And that's the sum of this. And then the structure total is equal to the concrete plus the rebar. And there we have the total price of the structure, which we're referring to as the entire set of concrete sections, is $5,000 $355.99.